So, good evening everyone, and again thanks for coming and joining this evening's meetup. My name is Norby, as it's written there, and I introduced myself a couple of times, but I saw a late joiner, so hi late joiner, I'm Norby. A bit about me. I'm, as I mentioned, the organizer of this lovely meetup group, so still looking for presenters, feel free to reach out to me. Besides that, a fun fact about me is that I've built an ISP like way back in a small village. At the peak of its existence, it had 500 users, 500 paying customers, and that little village had an internal forum as well as to what goes on in the village. And the crappiness of the service I've provided was a hot topic always, so I decided to stop. Anyways, it was a fun experience, and I still have a home lab. I have a cluster environment built. It's a great way to waste a lot of money and electricity and time as well, and run various useless services. So feel free to reach out to me if you want to hear about my home lab, because I can speak hours about that. But that's not the topic of the evening today. I would like to introduce you to Wasm, WebAssembly, and what it is and so forth. I'm going to do that because I love VMs, JIT compilers, programming languages, and the whole nitty-gritty details of that. It's a fun topic. I will share the slides, and there's a talk I did for JVM, which got recorded for the JIT compiler itself. It's like 40 minutes of JIT compiler stuff. Anyways, who here works with WebAssembly on a daily basis or regularly or anything? I have 2 people. So if anyone has questions, they know the answers. So I will also reach out to you if I'm stuck with a question. But yeah, so WebAssembly, yeah, of course there's a nice definition on their site which you can read. I'll summarize it. It's a virtual machine. It's also a defined set of instructions, and it runs your preferred programming language on your preferred platform, usually the web, but it has other options as well. This is their definition, so we trust that it's true. I'm also going to just highlight some of the main things about Wasm as a virtual machine as well, and as a solution. I think the key points are built-in security. We usually like to neglect security because who has time for that? They did not neglect it for us, so that's great. It's a capability-based engine, similar to what you see in various containerized solutions. If you're familiar with that, essentially it's the same. So you tell it what it can reach, and that's it. Deno also has something similar. What I think is really awesome is the streaming compilation. That's genius. It means if you have a big Wasm file, like usually we have big JavaScript files, right? The browser has to download it, the user waits for it to download, and then it starts interpreting it and so forth. Not with Wasm. It can start compiling while you're downloading. That's just pure genius. I wouldn't have figured it out on my own, but they did luckily. Supposedly they have rapid compile times. Everyone says the same. I put it there because it seems to be true. I'm not sure whether these gentlemen share the statement. No, so someone's lying on the internet, shocking. And I think the other important concept is the host environment. So Wasm always assumes that it's a sidekick somewhere. So if you take Batman and Robin, that it's the Robin of the evening. We will see that, again, that's not necessarily true, but that's the assumption. And last but not least, open standard. I personally prefer open standards because that means that there's an option for multiple people, companies, and so forth to contribute, and it's less likely that it goes down the drain. Now, in practice, the web is the same, or in theory, the web is the same. In practice, it's usually controlled by tech giants. So most likely, the case is similar here. But anyways, I think usually we can talk about, yeah, what's it useful for? I think it's always, how it goes is that someone imagines that I'm going to build a tool and people will use it for that, what I had in mind. But when you distribute it to clever engineers, they end up with all kinds of use cases. And I think that's really awesome. I'm not going to list everything. As you can see, there's a broad scope of what it's capable of. I think in the browsers nowadays you're going to use it whether you realize it or not. For example, I use Figma on a weekly basis, not on a daily basis, but that means I regularly use WebAssembly. I think there's also a cool story with AutoCAD that they took their 30-year-old code base and were able to port it and compile it and run it in the browser. That also is a great example of how well it works. And personally, I hate working with .NET, but I still put Blazor there because that's, again, a brilliant solution. Their main idea is that nobody wants to write JavaScript, shocking, and that you can do everything in C#. They compile the C# code in Wasm, they take care of the bridging, they hide JavaScript from you, and then you can build a web UI without touching JavaScript. Again, it sounds nice in theory. In practice, you are going to touch JavaScript. But regardless, other fun things, Shopify, like Drew mentioned, e-commerce, they have an excellent function as a service-based approach with Wasm, that you can upload your code and run it. They don't trust you. Wasm doesn't trust you either. That's why they feel so confident in doing that, because you cannot do anything malicious with it. And yes, serverless. As I said, I like my servers, so I shun away serverless, but it's still an option. Edge computing, meaning IoT, you can throw it out there and it runs. You're not running a Docker image, you're not running Node.js, you're just running Wasm. And CLI and embedding. I will get back to that later. But let's start with getting our hands dirty. So what? Who saw the What JavaScript talk, that legendary? It's so few people, I'm going to have to share it. Anyways, that is the simplest form of Wasm. So it's the textual format of WebAssembly. It's the simplest, not the easiest. Meaning, if you ever written Lisp, like Clojure, Common Lisp, whatever, Emacs Lisp, anyone, then you've seen these symbolic expressions. Or if you did AST manipulation, then it's also a common data structure. Essentially, in the parentheses, you have a bunch of items, the first being the kind of the keyword as to what will happen, and the rest is just inputs to that. So defining a function is very simple. We give it a name, some parameters, and note it, whether it has a return type or not. I think it's pretty readable. Executing actions is a bit tricky, because if you remember the definition, and I did not highlight that part, but it says it's a stack-based virtual machine, meaning it works in a way that you put stuff on top of the stack. If I execute an addition, then like here, what I would do, it takes the top of the stack off, does its operation, and then puts the result back on top of the stack. So that's kind of how it works. I don't know the main reason why they choose this, but it seems to work for a lot of people in the world, so I think they did the right decision. But that's all there is to it. And if you want to make your function available elsewhere, you export it. Now, how do we use it in a browser? Before we get to that, again, I would highlight roughly the relationship of Batman and Robin. Batman being JavaScript, Robin being the Wasm runtime. So still, you develop your JavaScript application, you put it on a web page or upload it somewhere, and then you load your Wasm application written in whatever language you prefer. Can be JavaScript as well. And then you do your magic. And I will highlight the importance of this setup, but again, here the host is the browser and JavaScript. And Wasm is a sidecar we are using to offload some of our work. So in practice, using it is very simple. There's of course an API in the browser which you call to kind of load your file. You can load stuff in the browser. I think every one of you has done that already. And then you just call it like a regular JavaScript function, nothing magical. And if all goes well, you see this lovely alert box that, yeah, your function was called, and that's it. Here it's pretty simple because we're just capturing the return value, and we're happy with that one. Okay, this was calling Wasm from JavaScript, but we would also like to turn it around. So what's our favorite pattern in JavaScript? Yeah, well, 10 years ago it was callbacks. Nowadays those are not so trendy anymore, but I still put it here because I've been doing JavaScript for too long. The other way around is also pretty simple. As expected, there's a way for us to pass some context into the Wasm environment. There we can also define functions like a simple DOM access with a query selector. And then in our Wasm code, we just say that, hey, by the way, there's some imports in the context I would like to declare. We just declare here that there's a function probably waiting for us, and then call it later on, and bam, the magic works. Our document model gets updated. The console is also there. We are happy. So the usual callback pattern works here as well. Now, this was on the client side, so browsers, but most of us are also working on the server side with Node.js, right? So can we use it there? Of course we can. It's also pretty straightforward. It's simple. The main difference is how we fetch or get our Wasm file. The APIs are all the same there. So nowadays, Node.js supports this out of the box. You can find it in their documents as a listed supported module, and then, bam, you execute it. It works. You're happy. You don't have to do anything, to be honest. If you downloaded Node, you have a Wasm VM ready and waiting for you. That's all there is to it. Now, if you read the documentation, like everybody does read the documentation, it states there are some limitations, the small letters, like meaning you cannot access most of the OS stuff. This doesn't seem like a big thing until you start to think about it. This means that you cannot do anything practical. That's the truth. So, and that's also a nice thing about it, and that's also intentional design decision about it. You should just move your logic into Wasm, execute it, especially if it's heavy computation and so forth, and then the rest of the stuff you need to do with the host, JavaScript, for example. But it's okay, it works, and as you saw, there's a lot of examples, and people are able to pull this off, but there's still a limitation. Fortunately, other people also realize that it gets tedious after a while. So there's another initiative going on now next to Wasm. It's called the WASI initiative. And it's about essentially just making a system interface also available to the Wasm VM. It's nothing magical if you think about it. It's what we are already used to dealing with. Like, for example, the Node.js example that I showed you on how we are loading a file from our file system. That's also an OS operation. The only difference is that the Node.js implementation is abstracting away the platform-specific implementation. For us, we don't care. We already have an abstract API that we are using, and we are happy with that. This is essentially the same thing for Wasm. They have a nice API which you can also include directly in your application. So you can use it directly, or you can say that I will rely on my preferred platform to do the implementation details, and I just want to focus on my application. Now, it works. You can try it out, but it's experimental. I think I have to highlight that. It's moving along nicely, but there's a lot of activity that has been happening this year, and you will bump into some difficulties or unexpected things along the way. So I just try to just throw away Node.js, because who needs Node.js, and build a complete Wasm-based Node-like server. So here what we are doing is we are taking a Wasm runtime called Wasm Edge. We are taking WASI as an API and Quick.js as a JavaScript runtime implementation. It's all running on Wasm. There's no Batman here. Now this is Batman all by itself. So the host environment here is the actual operating system, nothing else. And this works because the WASI, so the kind of the Wasm Edge providers did the abstraction implementation for WASI, for the HTTP module, so that's done for us. We don't have to deal with WASI directly. And Executing it is very straightforward, not. So yeah, you have to call the VM like you would call Node.js and MyScript, except that you also have to define what it can access. So how can it load our server application from our host file system if it's not exposed? It cannot. So you have to expose, give it access to our this is my current folder I'm working in. It's the same as in Docker. If you're used to that, you can also do it there. And then it should be able to access our file now. And then we are going to execute our JavaScript runtime, which is compiled to Wasm already. And then we are going to tell that Wasm runtime to load that file from our mapped file system so it can start our server process. It seems very straightforward. Once you figure out all the flags, it is. And then, bam, it works. You have an echo server running, working. If you send it something, it will reply. Would I use it in production? Hell no, but it works. And we can go even further. So I just showed you one aspect of it, but there's other cool aspects. So of course we can write command line applications as well. That it's a bit simpler, but there we can completely avoid the JavaScript runtime. So now what we are doing is that why would I need a JavaScript runtime to execute my Wasm application, right? I have a perfectly written header service. I want to call that directly. I have the option of that to invoke it directly. So let's do that. It works as you expect. You say that call my exposed function with an argument. It works. This works because the runtime, the Wasm runtime itself, has the interaction with the host environment through WASI. And then you can also, what I really like, so this was actually my main use case, the embedding approach. And I'm here showing a Python example because we already saw the Node one. But you can easily load it to any kind of application or written in different programming languages. So in Python, you just say, yeah, hack my model loading system because that always works wonders, and then import this Wasm file for me, and it works like a Python code. Behind the scene, there's a lot of magic, shuffling values around, but it works. It's very easy to do. If you try to do a foreign function interface for any language in the past, who has tried to do a foreign function interface? Did you like it? Yeah. That's also my experience. So it's very tedious to get something accessible directly. Sometimes because of performance reasons and so forth, having distributed services is not necessarily an option. Then you go hard and go directly through metal and whatnot, and then your eyes will bleed. So that's fortunately works pretty simply with Wasm. Now we can go even further. This is a point where I would say I wouldn't necessarily go any further than this, but this is a talk, so we'll do it. There's also another initiative that's building on a not yet finished initiative. That's also, so this whole thing is like very stable and reliable. But essentially someone figured out that, look, I mean, these WASI guys are onto something, but they are very, very treading on very safe grounds. They don't want to expose too much. The heck with that. I know that these other functions are safe. Trust me, there's nothing that can go wrong. So they exposed a bunch of more stuff to the Wasm runtime. And they stated this is also open source and everything. They're just doing it kind of more proactively because the standardization process is slower. So it's not necessarily a bad thing. I'm happy that there are people out there who do this instead of me, and I love them for it. So with this, you can actually now run lots of things on Wasm, including Mozilla's SpiderMonkey JavaScript runtime. So if you use the Mozilla browser on a daily basis, you're using SpiderMonkey, they have that working. They have a proper full Python environment working. They have SQLite working. They actually announced this week, this is the Wasmer guys, that they have a new service, which is a Rust implementation of a service worker without the dependence in the browser or anything. And then you can just use SpiderMonkey and their service worker implementation to do serverless stuff. Very lightweight. In a sense, it makes sense if you're running on, I don't know, IoT devices or so far, or if you have lots of small VMs you want to spin up for handling different clients. It's nothing new if you think about it. It's been done with virtual threads, green threads, and so forth, actor patterns, but it's a different way and it's completely isolated. And I think that's an important factor, the amount of security you get with this approach. So there you have it. You can try it. It's actually available on their site with some caveats that, yeah, it's a technical preview and you might run into issues, but they are pushing the boundaries, that's for sure. And from my side, I would say I would finish up with some conclusions. I would say facts, but you know, these are really just my personal opinions and my personal observation. I think that I talked about various runtimes, right? That there's Wasm time, Wasm edge, Wasmer, and so forth. They all focus on different aspects and different things, whether it's security or performance or memory footprint. They have a different focus. So you really have to know your use case, ideally, what works for you. But it doesn't. But they also can overlap and cover everything in general. So for my use case, it was about having a way for embedding untrusted code and plugins into an existing service. And for that, Wasm time works perfectly. I just define what's available to the plugins, and it's just a purely referential function, so function as a service. There's some inputs, it returns a result, and I'm happy. I don't have to deal with difficulties, it works. The other runtimes have a different focus, like the Wasmer people, they're really providing a Docker alternative as well. So they have a registry, you can upload your service to their servers. You don't have to deal with all this, they take care of it for you. It's up to you whether you accept the risks or not, but essentially they provide everything open source, so it's not a huge risk. And yeah, the edge stuff, that's for IoT. They really focus on QuickJS, small things. That's their main appeal. All have, to be honest, they all have their, yeah, this is not yet documented, we are working on it. So it's not an easy ride either way. And this is the kind of the thing, the amount of, yeah, it's not working, yeah, it's like the Shopify blog post, that was awesome. It was 2 years old, and yeah, we are investing heavily in Wasm, and we believe in Lucet because we know it's a stable solution. Like, oh, well, okay, let's look into Lucet, and what greets you there is end of life. And like, it was like 2 years ago, and now it's already end of life, and go to the other place. And that's a lot what you find here, like a lot of experiments and a lot of things you need to figure out on your own, which is great if you have the time for it and the willpower, not so great if you have a deadline that you need to reach. So again, I think anything above the browser or above basic WASI stuff is going to be tricky and risky. And last but not least, what it means for JavaScript developers, whether it's going to replace JavaScript or not. No, I would say not in the near future for sure, because as I showed earlier, you must rely on JavaScript to achieve anything useful. But there's a but, of course, because as a Blazor showed, or a Qt as well, there are ways where you can just avoid this and trust your framework to take care of it, which is a nice thing. But anyways, it opens up additional possibilities for you. Like the embedding use case that I mentioned gives you additional libraries and options as a JavaScript developer that you can very easily integrate. Usually you don't even have to set up a build chain or anything. If you quickly want to try it out, you can just fetch a release from GitHub, load it up in your application, and it's working. That's all there is to it. And of course, I showed that we write assembly by hand. You shouldn't do that. If you know TypeScript, you can easily just use assembly script and it works. That's kind of the addition function. It would behave the same way, but it was funner to start with the assembly text. Last but not least, I think that's the most important. JavaScript won't get you far with Wasm if that's all you know. If you want to head down that road, be prepared to reach out to something else, like Rust, for example, because that's pretty popular here, but that there's other solutions. Like Kotlin is releasing a Wasm compiler as well. There's a Go support, C# support. So essentially, I'm sure you find another shitty language to deal with Wasm besides JavaScript. So this is all from me. So thank you for your attention and time. And then if you have questions, we will have a Q&A in 5 minutes. But I will hand it over to you. Thank you.